Hello. In the last video I showed you how to control FluxGrip using an Arduino, whereas in this one I will be showing you how to control it using a CAN port. In this tutorial I will be using CanFace 2, which is the bigger version, as you can see here. There's also a smaller version that you can find in our shop, which is called CanFace 1. Just to show you, here is CanFace 1. It's basically the same device, it just has only 2 CAN ports, whereas the CanFace 2 has 4, as you can see here. For our purposes that's not gonna matter, however. I will be doing this on Windows, which has one downside. Windows support of CAN interfaces is kind of patchy, so it will not work as well as on Linux. This can be found on this forum post, FluxGrip system test. It's the second reply to the post. So let's get started. Okay, so first step is installing Git. Okay, so 64. Feel free to skip this part. Next, 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 next. Don't forget to like and subscribe. Alright, let's see what the next step is. Okay. Let's put this here. Finish. Alright, let's see if it works. Git version. Okay, it doesn't. Perhaps we should restart then. Okay, there you go. Now we need to install Python. 64-bit. I'm using Windows 10, so that's okay. Let's install this. .64-bit. There we go. Now, I know this might seem very obvious, these steps, but I just want to show everything, absolutely everything, because Sometimes people have questions even about the simple stuff. Not pointing any fingers. I would like to repeat that if you're actually serious about embedded development, you should really consider moving to Ubuntu or any other Linux distribution, but Ubuntu is probably a good place to start since it's relatively beginner friendly and works out of the box most of the time quite well, I would say. At least better than Windows. Okay, is it done? I don't get it. Is it? Okay. Okay. And now we should have Python as well. PowerShell. Let's go. Python. What? Or is it not? Okay, let's restart it again. Okay, why is it not working? Let's check it in the terminal. I don't really understand what the difference between these two is, but apparently there is a difference. Wonder if this command works. Okay, grok how to check in PowerShell if Python is installed. Let's do this. Strange. Okay, I will continue and hope that everything works. Perhaps this is the issue right here. So, let's go to this tutorial. Edit system. Edit system. Go to environment variables. Add the Python path to path in system variables. Let's add it to system variables so everyone can use it. Edit. Now we should just check whether it's actually there. Users. app data, local programs, Python. Okay, just copy this, new, Control V, new, Control V, scripts. Okay, okay, okay. Now hopefully this works. And it does, yippee. Okay. Now we install Yakut, which is a tool to inspect Sci-Fi networks. If you don't know what Sci-Fi is, this is the website. It's pretty cool. Unfortunately, Pavel has a very complicated way of explaining it, but it's basically a protocol to share information between different devices on a vehicle, a pub-sub protocol, you could say. And it has a lot of cool stuff that's unfortunately a bit difficult to use at times because there's not a simple to use GUI, which is an upside and a downside, because once you get away with the CLI stuff, you kind of don't want to go back either. So okay, let's move on. Pip is installed or not? Pip is installed. Okay, so we can install Yakut. Pip install Yakut. I think I should probably add timestamps for the setup itself and then the actual turning on and off of the magnet, which is not that long and complicated. It's already 12 minutes and I haven't even... Yeah, okay, it's almost done. Jesus Christ. Actually, this is a very old computer, so it makes sense that it's a bit slow. In fact, we don't really have any new computers here. I bet it doesn't require a lot of compute power, so I guess it doesn't really matter. Anyway. Let me know if you wanted me to do a tour of the office type video. I think that would be pretty cool. I'm just kind of interested in having a bit more of an online presence for the company. I think that would resolve a lot of our current issues with people not knowing who we are and that we make pretty cool stuff. Let's go to our website. Yeah, recently I made this attachment piece for a Mavic 3 drone. You can basically print it out using a 3D printer and attach a magnet and then use the LED that's at the bottom of the Mavic drone to magnetize and demagnetize. It looks like this. Anyway, it has finished installing Yakut. Let's check it. Yakut version. Okay. Now we create a folder called FluxGrip. And we go to this folder and copy the DSDL files. These are called. Perhaps I will try to explain it as well while it's okay. Now it's going to be quite quick. Basically, these are the data types that can be transmitted over the network. These are the standard ones. They contain like the integers and stuff like that. Actually, we can go here and have a quick look. So if you go to UAV count, which is like the old naming scheme, I think node should have the heartbeat, which is a standard message that every node needs to send out in order to know that it's online, and basically it reports on its health, any vendor status, vendor specific status codes. Actually, I can probably show this when I have the magnet connected. And this is the company specific data types. In the case of the magnet, it's actually only one type of message, which is the feedback. Basically contains a boolean and an integer of 3, which tells you whether it's magnetized and what its current status, and also amount of cycles it has turned on and off. So pretty simple, really. Okay, we have cloned both. So we need both because we'll be connecting to the magnet, which relies on both types from the public repository as well as types from the company specific one. Okay. Let's go to this folder we just created. I think it's in the home directory, so I guess we can just go here. What users? Here, yeah. Okay, and here is FluxGrip. These are the two. Actually, you can see it's the same as I showed you before. And now we need to create an environment variable script. Just new file, text document, I guess. Yeah, I don't really use Windows a lot, so I'm not like completely sure how this works. Okay, this one, and then we copy these environment so what this does is it basically tells Yakut where to look for all the necessary types, and as we just copied them to this folder, Sci-Fi path is basically the environment variable which tells Yakut where to find these types. And then there's UAV CanFace, which is the CAN interface we're using, but we will need to probably update this. And these are all related to the CAN bus itself. So here it's MTU. I think it's a parameter for CAN bus. CAN bus MTU. I'm not sure what it actually stands for. I think it's like bytes per message or something. Gog.com. What? Actually, yeah. No, perhaps it's set on by Savfel. Let's check it. I think here in the demo MTU. Let's it doesn't really explain what MTU means. What does MTU mean? Maximum transmission unit. Okay, so yeah, it's size of the data payload in bytes. Oh, there you have it. The bitrate, I think that's obvious. There's two sorts of bitrates. And last but not least, the node ID. We will be using Yakut to automatically find one that works for the magnet. Given that we have an empty network, it doesn't really matter, but it will automatically set one that works for us. Okay, so we've done that. Now we need to go to and see what the actual interface number is. So let's go to Device Manager. And it's under ports. Okay, and I will just disconnect it. It's showing up as a lot of them. 6, 7, 8. Okay, let's just try 8. There you go. Okay, save this, close it, and then run PowerShell as administrator. PowerShell. Now we just switch to that location. Yes to all. Do you want to change the execution? Yeah. Okay, now we can first execute our environment variable. Why not work? Damn, it's a text file, so I think I should probably change the type. Go here, edit. Is there? Okay, let's ask Grok how to do this. to create it's still the same. Okay, we just create it from scratch. Files, save as, all files, and ent.ps1, save. Alright, now it's correct. Now this should work. Okay, it's compiling the data types, and after that it should give us a node ID. Yes, 64. And now we can run Yakut monitor, plug and play. And there you have it. The magnet is node ID 125. These are all the messages or topics, and these are all the services that are present. For our purposes, we are interested in only one, and actually we need to set it first. Jump to the end. Should probably remove this under construction part, because the registers is already part of the. This is how you do it in Linux. It's actually a bit shorter, at least from my point of view. And now we need to set this register right here, which is called command ID, and this will allow us to control the state of the magnet. So let's exit this. Yakut register access 125, which is our magnet, and uvcan.sub.command.id. Now we just are reading it out. I think it should be none at 65,535, which is, I mean, basically it's not set. That's what that number means. We're setting it to 1000. And now we can send the command to the magnet to restart. I think that's the correct command. Yeah, and actually you can now see that the magnet has been turned off, and it should be rebooting. Yes, it has rebooted. Now let's go back to monitor. And actually the downside with Windows is that you can only have one window. So it should be called window instead of Windows. It won't work with two windows open at the same time. There's some technical reason for that. Monitor. Okay. Where is the... here. Sorry. So now we see here message topic ID 1000, which is the command ID. Basically, when we publish to this topic ID, the magnet will pick it up. As you can see, now there's no data on this topic ID. These are the bytes per second, I think, and right now it's 0. And then the next step is publishing something. I mean, not something, just an integer basically. Oh, I do, okay. Yeah, good, pub and 1, which is, I think, means that publish this once. UVCAN dot primitive dot scalar integer 8 1, and this should turn on the magnet. Jeez, it's working slow. Okay, it has turned on the magnet. Now we do 0, and this will turn off the magnet. Actually, I should probably switch to this view. So now it's blinking twice, which means now it's turning off. Okay, so now I can remove it. We'll do it once more. Turning on. Okay, yeah, it's turning on. Actually much faster on Linux. I'm not sure what the holdup is here. Okay, so there you have it. It works, and now you can control the magnet using Windows and using CanFace.